So you probably already know the basics of polynomials, right? You probably already know what a linear and quadratic or a cubic polynomial is. In today's video, we're going to go more in depth and start off chapter 2 discussing the names of basic polynomials. So the first one you're going to encounter is you need to know linear, which you probably already know, and then cubic and quadratic. I'm going to put you might not need this. This is an extra one, quartic. Quartic is to the 4th power if you don't know. So linear is any polynomial. So we're going to denote polynomial as p of x, right? And this is like x plus or minus k. And actually what I should do is ax, right, the coefficient in front, ax plus or minus k. In other words, we don't need the plus or minus, I can just write p of x equals ax plus k. That's p of x, that's a linear polynomial. The linear polynomial has the degree of 1, and the degree of the polynomial is, if you look at a polynomial and you have like all these exponents, usually, like I'm going to give an example, like x cubed plus 2x squared plus x plus 1. This is the cubic polynomial, and it has a degree of 3 because that's the largest exponent you get after you combine all like terms. So that's a linear. Cubic is p of x equals, you have ax cubed plus bx squared plus cx plus d, where a, b, c, d are all constants. Again, this has degree of 3. If you look at the largest exponent, it's 3. So you can write the degrees. It's degree 1. This is also a degree 3 polynomial. Quadratic is p of x equals ax squared plus bx plus c, where a, b, and c are constants. Now, you probably have more experience with quadratics, finding the zeros of a quadratic. We'll get to the zeros in a second, but finding the solutions to a quadratic equation. So this has degree of 2 because of the exponent in the front. Then the quartic, again, it's kind of extra. NCERT doesn't include it, but that's just if this was the first exponent was 4 and then you had bx cubed. That's just like an extra thing I put in there. So don't spend too much time. You don't need to study this. It's just like an extra thing. So now we know the basic polynomials. You need to talk about notation. So if I have a polynomial p of x, let's say I'm going to give it a p of x. Let's say we have a quadratic. That's ax squared plus bx plus c. Then if you ever see like find p of k is just if x equals k. So if x equals k, what would be the value of this? So that we just substitute k in for x. So this is a times k squared plus b times k plus c. That's p of k. So the best way, this is illustrated by using an example. So if I have p of x equals x squared plus 4x plus 5, then if someone asks me to find p of 3, then that's just, okay, x equals 3. So this is 3 squared plus 4 times 3 plus 5, which is 3 squared is 9. 4 times 3 is 12, so we have 12, 9, and 5. 12 plus 9 plus 5. 12 and 9, 5 is 14. This is 26. So that's how you find the values of a polynomial when they ask like p of k, when you give them p of x. So now we can talk about zeros. What are zeros of a polynomial? Zeros of a polynomial are the value p of k for which p of k equals 0. So if I have polynomial p of x equals like something, and so the zeros are the values for which values k for which p of k equals 0. So for an example, if I have the polynomial x squared plus 4x plus 10, then the zeros of p of x are the values for which p of x equals 0. And you can use k, but whatever. So p of x equals 0. So if I have x squared plus 4x plus 10, that's basically x squared plus 4x plus 10 equals 0. And we need to solve for x. And the values of x that make this equation true are the zeros. So that's true for any polynomial that we discuss. So for example, if we have a linear p of x equals x plus 5, then the zeros are just the value for which p of x equals 0. The values for which p of x equals 0 are x plus 5 equals 0, and then you get x equals negative 5, so there's only one 0 in this case, which is x equals negative 5. Alright, so now we know what zeros are, and we know all the polynomials. We know how the notation of like p of k when you solve for certain values of the polynomial. Now we can actually start to talk about the geometric representation, which is in your textbook. Scroll down. They've done like graphs. So in linears, and you basically need to know like when you have a 0, what is a 0? A 0 of a polynomial is the value of x. So a polynomial is like a function, right? If I have p of a polynomial is a function, so you have ax to the something, right? Now, let's say it's a cubic plus bx plus squared plus cx plus d. This is a cubic polynomial. We want its zeros. We can imagine like graphing this because it's just a function. We can just graph it. If we imagine graphing this, then the zeros are for which p of x equals 0. So when this thing equals 0, right, that just means whenever y is 0 on this graph, right? Whenever y is 0 means where's y is 0? Here's the origin. This is 0, 0. Up here you have y values that are greater than 0. So y is not 0 anywhere with this line, which is the x-axis. So you want to know the zeros of the polynomial are every time the polynomial intersects this x-axis, that's how many zeros it's going to have. You can also determine the zeros by graphing. So if I know, like, if I have a parabola, right, it just touches a single point right here, it's tangent to the x-axis. This is like negative 5, 0. Then I know the only 0 of this, for example, this is like p of x equals like some ax squared plus bx plus c, that's the graph. Then I know the only 0 of this is negative 5, 0. And that's only 0 of this function. So you're gonna see a lot of problems where they ask you to find the 0, how many zeros does this function have, and they give you the graph. And then so let's try one on your own. It's probably pretty simple, like just for the sake of practice. How many zeros does this function have right here? The graph, this function. How many zeros does it have? Pause the video, figure it out, and I'll promptly provide the solution. So for this one, crosses the x-axis at 2 points right here, meaning it has 2 zeros. It's a parabola, so parabolas usually have it either intersects the x-axis twice, or like right here, it's tangent to the x-axis, so there's only 1 0. So that's the case for the parabola. Or the third case, just if you're wondering, for the parabola is if you have your axis and then the parabola is just up here. That means it has no real solutions. So in the real numbers, if you talked about real numbers, this is the real plane. That means the parabola has no real solutions if it's up here and it doesn't ever like touch or intersect the x-axis. And this doesn't apply to parabolas. Like if I look at a linear function always has 1 0. That's just a characteristic of a linear function. It always has 1 0. And that 0 is again the point where it crosses the x-axis right here. And for cubic is again just like the parabolas. It's not as important to know like the different types of cubics or how many solutions and stuff, but just generally know that the amount of times a function will cross the x-axis, that's how many solutions it has. Right? If I have this graph right here, and it's kind of like a cosine function, but we'll get to that later on in our series on the NCERT 10th grade. But here we have how many 3 zeros, and it's going to go back again. But if this was just the entire graph, and how many zeros does this have? Well, 1, 2, 3, 4. And this is pretty simple for the graphs and figuring out the zeros. That's all for this, for part 1. We're going to dive right in part 2 to some more challenging problems.